Oh, welcome back. Okay, so continuation of from the last session, and the last session we cover up to step number 7 to how to read the data file. So we'll continue from the step number 8, write a syntax to manipulate and or analyze data. And actually, step 8, 9, 10, those are iterative steps. Okay, so in my presentation, I present the steps 8 and 9 together. Let's do something with the data. So I chose to, well, of course, that this is just an example of what you can do, and this is very simple, but I thought it is simple enough, but very useful for many instances that where you're interested is exploring the data that you have in your hand. Which is the running the descriptive statistics. Okay, so the screenshot you are seeing on the screen up to the line line 4. That's the steps that you wrote you read the data in. Okay. So in order to run the descriptive statistics, there are actually many different ways to run the descriptive statistics on the R or RStudio. So what I chose was the function called the describe, which is a part of the package called the psych. Actually, it is a huge package. Author wrote there, his own and gathered the other functions available on the R, specifically for the psychometric or psychological research or psychometric research, so which includes the advanced latent model analysis, like a fact analysis and IRT and other models too. But at the basic level, I found this function to run the descriptive statistics quite useful, and I like it. So in order to do that, we have to install the package called the psych, okay, and then load the package, and then use the function called the describe. So so that's the what you see in here. And if you look at the line 7, it just said the describe and the name of the data file that I have written. Okay, so if we do that, it will run the descriptive statistics for all the variables that we have in the data object, and then that may be or may not be what you're interested in, right? For example, when you are using SPSS to run the descriptive statistics, you don't run the descriptive statistics for all the variables you have in the data file. Your data file may have 250 variables or even more, and you don't want to do that. So I will show you how to select the variables later on. But at this point, so let's say that the assumption is that your interest is to run the descriptive statistics for all the variables you have in the data set. And what you see on the line 8, it has the additional keyword. It says a fast equals to T, T for true, which means that it will output the abbreviated output. So I will show you how it will look like. But the way I run on the line 7, shows you the very long output. So line 8, it will truncate to the seemingly most widely used statistics. So let me go for the actual R code, and let me run the first 3 lines to read the data in. Now the data has been written. Okay, the Chapman data that we've been playing with. Okay, and then load the psych package. Okay, so actually, since last time, I found a way to handle the not installing the packaging over and over by writing the install packages command. So this is actually the statement I said, but I wrote the if statement. So basically saying that if this package is already installed, don't install. So that's the this command is, or to be more precise, if the package is not installed, then execute this install package instruction. So I can show you that I already have the cycle package installed. So if I run this, it doesn't install. But if your computer doesn't have this package not installed yet, it will execute the install package command. Okay, so but I have to load the cycle package anyway. Okay, so here is the line 7. Is it same line number as a slide? Yes, it is. That's good. Okay, so let me run this line 7 and then pay attention to the console output. As you can see, it has a lot of the information actually. So it's starting with the variable number, and that's a frequency of the frequency count for each one of the variables, the mean, standard deviation, median, tree mean, mode, median, minimum, maximum, range, skewness, kurtosis, and standard error for the mean. But sometimes you don't need all of those. So what I do usually, my preference is that almost always I provide the fast equals to t keyword, so that it will provide the more abbreviated output like this, which contains the mean, standard deviation, minimum, maximum, range, and standard error for the mean. Okay, so that is I found that it is the more convenient for me. So, but as I said earlier, it will run the descriptive statistics for all the variables you have in your data file. In this case, unfortunately, we don't have a lot of variables, but it runs the descriptive statistics for the variable like ID, which is nonsense. Okay, so typically, we don't run this describe function for the entire data set. We have to go through some sort of the selective process. So that's what I'm going to talk about next. All right. So this is next slide is a little bit of a sidetrack again, but well, many people actually ask me, how do you know how to do on R? Okay, see, my short answer is that I don't know. Okay, I don't know everything. And also, even when I have to do the same thing I did before, basically I have to, search on the net. But there are certain ways that you can search more effectively, and I almost always look for a keyword and then attach another set of the keyword in R. So for example, if you're looking for how to do regression analysis on R, I will type in regression in R. Okay, if you're looking for something else like a factor analysis, I would say factor analysis in R. So, and then almost always you hit the right place. And of course, you won't be looking for one particular resource. It will output the many resources, because that there are many websites that where that the people ask questions and the other people answer. And also, many people have their own, websites to provide the tutorials, and so there are many resources out there. Yeah, and then once you start, looking for those, resources, you will get a sense, where is the reliable, sources, and actually, I have my favorite, web board where people ask questions and the people answers, but those are I would say that where you actually look for information, that is something that probably you will learn by your own experience. Okay, so I just copy and pasted the screenshot when I did the regression in R search, but you will see the several seemingly correct resources that you can look it up. Okay, so that's the way I figure out. So almost always, when I work on R, it's very rare that I don't need to look up the internet resources. I almost always, constantly looking up and the write a code, looking up, write a code. So that's basically the cycle of the that steps. Okay. Any question about that?
What's your favorite web board?
Stack Overview.
Stack Overview?
Yes, yeah. And also one recommended website. It is not a web board, but the website is actually showed up here, Quick R. And pardon me?
Do you use that one as well?
I used to. Yes, it's a very kind of introductory, and it's getting a little bit outdated because that the R, R syntax, tools is changing daily actually. And then, funny thing is that if I look back the what I did 1 year ago, you look kind of different what I would do right now actually. Yeah, so it's not really static. It's very changing constantly, and I see that this Quick R website is kind of getting outdated, but still it provides the very systematic and the very useful information too. Yeah. And also there's another website called the R bloggers. So there are multiple, I don't know how many people, 20, 25, or even 100 people who contribute the entries, but those entries are essentially a short essay on okay, this is what I wanted to do, and this is how how I solved. They're telling their own stories for instructional purposes, and then you can actually constantly checking that website, or actually that website actually feed onto your Facebook feed too, so you can you can receive their updated entries too if you like to. For example, or actually the R bloggers is the last one on this screen. Yeah, it didn't hit the Stack Overview, but that is the the site I frequently look at. Yes.
So when you were saying that Quick R is kind of outdated, I just want to make sure I understand the R environment. Does that mean that it would still work, whatever they're posting? It's just that it's not maybe the most efficient way to do it anymore?
Exactly.
Okay,
exactly. Yeah. Okay. Yeah. For example, our Quick R doesn't show the way I select the variables in the next slide. For example, it is a relatively newer way of doing it. Okay. Not here. Okay. The next slide. Okay, so this is the what I was talking about. Okay, how to select the subset of the variables, which is almost always required to run the descriptive statistic, for example, and as well as the other operations that you might be interested in. So again, there are many different ways to do this. And for example, Quick R shows them the different way, but this is my favorite way, which is to use the function called the select, which is part of another package called the dplyr. So it's almost impossible to stay with the only one package. So it happens in a way that when you look for, okay, for example, if you want to do some particular statistical procedure or particular way to manipulate the data, and then you find a way to do, and many cases you need to download a new package. Okay, so the download the new package is almost part of your routine to use R actually. Yeah. So please get used to downloading new packages. Okay, so
who makes the packages? Is it like
everyone,
one developer, or like anybody that?
Anybody. Yeah, I have not developed my own packages, but I could, and then I could post. That's how it works. Yeah, and you could develop your package too.
Okay.
Yeah, yeah. But this, there are well, actually, this dplyr package, developed by the very well-known R programmer, who also authored the many other very popular packages. And okay, step 8 and 9. Now we are going to select the subset of the variables by using the another function called the select, but it is again not part of the base packages, so we have to download the another package called the dplyr, dplyr, dplyr. Okay, so it goes like this. Line 10, I say install that packages and the dplyr with a double quotation to install the package, but the again, you only need to install the package only once. But line 11, I say library dplyr. Again, you need to load the package that is needed to use a particular function every time you restart the session. Okay. So the line 10, you don't need to run every time, but the line 11, you need to run every time you restart the session. Okay, and then line 12 is how we can use it. Okay, I kind of showed in the step-by-step how we can write the very efficient and the easy to manage syntax. Okay, line 12 actually, I'm not selecting anything, but I wanted to show you the use of what is called the pipe operator, or simply pipe. Okay, so I explained in the bottom part of the slide, but the pipe operator, this is a combination of the three characters, percentage and the greater or less than, whichever you read the sign from, and the percentage sign again. That is used to execute the series of the operations sequentially. Okay, so for example, it works in this way actually. Okay, the second point of the slide, I said, in short, the left-hand side of the pipe will be used as the first entry of the function on the right-hand side of the pipe. Okay, so let's focus on the line 12. I said chapman.dat on the left-hand side of the pipe. Okay, so that is going to be the first entry of the function on the right-hand side of the pipe. So the function on the right-hand side of the pipe is a describe, right? So the first, I have the empty parentheses, but actually the fact is that the pipe will move the that chapman.dat as a first entry for that function. So it would be equivalent to say describe in the parentheses chapman.dat. Okay, so that is the how this line 12 works. Okay, and then line 13, the same thing, but I added the fast equals to t. Actually, that is a second entry, but the first entry is still chapman.dat. So the line 12 and the 13, that's something equivalent to what we have seen before. Let me bring the slide back right here. Line 7 and 8, those are the equivalent thing to lines 12 and 13. Make sense? So you see, this is the actually at this level it is not required, but if you understand how the pipe works, it will make our life very, very, easy actually. If you have the like a series of the 10 operations that you want to do, you can use pipe and the boom, 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 sequentially, rather than writing a very long, one function. In traditional way is the write one function, nested functions in the like 6, 7, 8, 9, 10 functions nested within one function. That is confusing actually, very difficult to if you get it right, that's great. But if you don't get it right, what's wrong with that? It's very hard to detect the mistake that we make. But pipe makes our that kind of the very complicated series of the operation very easy actually, easy to debug too. Okay, so the real use of the um, um, pipe, this is probably the one of the simplest way, line 14th. First I set the original data set right here, Chapman.dat, and the second I select the subset of the variables, and then third I run the descriptive statistics for the selected subset of the variables. That's what I did in the line 14th. Can you see that? I said Chapman.dat and then pipe, and I said select. Actually, that is the function part of the dplyr, and the a list of the variables that I want to choose. So in here, I chose the 4 variables almost arbitrarily. Systolic blood pressure, diastolic blood pressure, cholesterol level, and the coronary instance, those 4 variables. And then put only those 4 to the next function, the function on the right-hand side of the last pipe, describe function with the fast equals t specification.
So we really don't need 13. 13 is kind of like what we did
Yeah,
before. It's just not using piping.
Right.
And then 14 is actually the 4 variables that we
Yes,
want.
exactly.
Gotcha.
Yeah. Okay, so I can show you on the R. Okay, so we are here. Okay, so now this install dplyr if you haven't. Okay, and then I load dplyr. Okay, and then the first one, well, maybe I don't need to run 12 and 13 just to make sure that those are not required. So let me skip to 14. Okay, and then if I run it, as you can see, it outputted the descriptive statistics, short version of the descriptive statistic table only for the 4 variables which have been selected. Okay. All right. Any other questions? All right. So I will do a little bit more. I will add another layer for the data selection cleaning. So now I'm going to show you how to select the subset of the cases and the variables at the same time. Okay, so that could be a case, right? So in this case, I hypothetically create a situation where I want to see descriptive statistics only for the people who had a coronary incident. Okay, and then select only those 4 variables. So that's the situation I created here. So in order to select the subset of the cases, again, there are many different ways to do. And for example, like Quick R website doesn't show this way. It shows a different way. But yeah, I found that this is a very nice way and easier to understand. But I use the filter function, which is also part of the dplyr. Oh, by the way, that the pipe operator is also part of the dplyr. Yeah. So in order to use pipe, you need to load the dplyr package as well. So all the pipe, filter, and select, they're all part of the dplyr. So now, even with those 3, functions, I hope that you can see how dplyr is useful in the data manipulation, and there are much more than those 3. Okay. All right. So this is how I did, and then I can write the our syntax in this more friendly manner to the human eyes, so that we can easily see exactly what we are doing. It is actually 1 line, but I separate it into 4 lines, as if that I write the I actually separate in 3 lines. I'm sorry, so that the selection of the subset of the cases and the selection of subset of the variables and running descriptive statistics as if we are running writing those 3 operations in separate lines. So that's the how I wrote this 1 long line. But again, are considered as this is a 1 line, so we have to hit the run only once. Okay, so the way the filter works is like this. For example, if we want to select the only cases which has the coronary instant, remember that the variable was coded 0 or 1, 0 for no coronary instant, 1 for yes coronary instant, have had the coronary instant. So I said coron, that's a variable name, equals to, but notice that I have put the 2 equal sign, double equal sign, that is our way to use the equal sign as the logical operator to make a judgment whether it is true or not. That's what I mean by logical operator. Okay. So essentially, it's saying that okay, we will select the only cases where that the coronary instance equals to 1, or that to be more precise, only choose the cases where that the condition we specify inside of the parenthesis equals to true. Okay. All right, and then put the pipe, and then go to the next operation, which is the selection of the subset of the variables, which is the same as I presented, and the pipe, and the last operation, which is the random descriptive statistics.
And what does the pipe signify again?
Pipe is the connecting the
lines of code.
Yes, yeah. But again, the rules stay the same. Whatever you have on the left-hand side of the pipe will be used as the first entry of the function on the right-hand side of the pipe. Yeah, but actually, there is a way to use the what you have on the left-hand side of the pipe as the in any location of the function. But I'm not covering that, how to do that in this workshop. But by default, they consider that okay, that's what you have as the first entry of the function that you have on the right-hand side. But there's a way to, manage. It doesn't have to be only the first entry. Okay. All right. So let's look at that line particularly. Okay, so this is a line. Okay, so maybe okay, so maybe I can run at once. Okay, all right, I will run, and I will get this. Okay, so if you compare to the original analysis right here, with all the observations, which had the 200 observations, and now this operation that I run right now only run the 25 observation, which are the people who have had coronary instant. And you can see that if you look at the last variable, coron, it's quite clear that the minimum equals to 1 and maximum equals to 1. So that pretty much saying that everyone had a coronary instant. Okay. All right. Any questions? All right. So that's another example.
Really quick question.
Yes.
Is it possible to filter by more than one variable?
Yes.
Okay. Would you just put a comma in between the names that you're interested in?
No. Okay. So I will show you how. Okay. So when you say filter by more than one variable, means that you are imposing more than one conditions.
Yes.
Yeah. So you have to say, okay, one condition and another condition, and then you have to say either or and. Yeah. So I can give you an example. Okay. If you want to say coronary incident 1 and let's say cholesterol level higher than 300, or something like that. So this will, screen the people who only had the cholesterol level higher than 300. So I can run this quickly. I'll just show you and compare to the previous one. Okay, so now only 15 people. And if you look at the cholesterol level output in the previous, descriptive analysis, minimum was 178. Okay, but right now, minimum is 302. So that pretty much verified that that screening worked. Okay, and then if you want to use those two conditions, not to connect by and, which means that or if you will use the vertical slash. So in this case, we will screen, filter the observation coronary have had the coronary incident or cholesterol level higher than 300. Okay, so if we do that, okay, so he screened the filter the more people, 86 people. Okay, so this is the subset of the observations, who satisfy either one of those conditions. Okay, all right, and you can do multiple conditions too. Okay. All right, let me go back. Okay, so the next step, okay, step 10, save the work. Okay, you want to save your work, right? Okay, so if you follow my slide, at this point you haven't saved your work. Okay, so you have to save your work at some point before you finish your your session, because you want to come back to the session to continue the work. It's very rare that the 2 hours you work on this is it, right? Or even in that situation, it's a good idea to keep your work so that you can reproduce exactly the same thing you produce this time. So this is how to save the work. Okay, so the one way to do is that they just click on the this save button on the screen, and it pops up the dialog box to choose where the script file should be saved. And usually, my experience is that the RStudio will show you that you're working directly as the first place to save. So, but I recommend that you double make sure that that's where you want to save your file. Okay, and then once your work is saved, you can continue working. But I recommend that you occasionally save it, and before you close the session, you need to save your work again. Okay, any question about the saving your work? Okay, and then this step is just a part of the iterative steps 8, 9, 10. So this process will iterate. So go back to the work after you save the script file. You go back to work and write more syntax to do other things, and then run it, and then save, and write, run, and save, and repetition of that process. Okay, and then if you really finish the session, that doesn't necessarily mean that the completion of your work, but the time is up, and you have to terminate your session, and will have to come back some other time. You have to close RStudio. Okay, I highly recommend you close RStudio. But before doing that, again, be sure to save the syntax for the last time. Okay, but RStudio is actually nice enough to cache whatever you had, right before you close. So even if you forget to save your work, RStudio will bring back what you had, right before you close RStudio, which is nice. But I wouldn't take advantage of that feature. That is really the feature that can save your work in case you forget to save, or some other, emergency situations. Okay. So again, be sure to save your syntax for the last time before you close. And then to close the RStudio, to program, just like the closing the other programs, then if you go to the, the menu, there's the menu, submenu called the Quit RStudio. Okay. And then you'll be asked, okay, this dialog box, would you like to save the workspace image? Okay. Well, long story short, my recommendation is don't save the work image, okay? Because there is a possibility that if you don't know what you're doing, you can mess up the other things actually. And then as far as your script file is saved, you can easily recreate the exactly the same situation that you had before you close the RStudio. Okay. Of course, there are certain purposes to save the workspace, but at this point, as an introductory session for the RStudio or R will, if you run in R without RStudio, they will ask the same question. My response will be the same. Don't save the workspace image unless you know what you're doing. Okay. But I can give you the couple of the cases where you want to save the work image. But one definitely is a case that the running the entire script takes so long time that you don't want to waste your time next time you come back to your work. Okay, so I'm not talking about the it takes 10 seconds. 10 seconds is not long time. Okay, I'm talking about like few hours to run the entire script to go, to come back to the where you were. All right, so but I can discuss with you, if you still don't understand why we don't have to, save. But the long story short, the reason is simply that you can quickly recover where you are by running the script file. Just spending a couple seconds to do that. Yeah. So that will.
Paste the script, the code, the syntax.
No, script. Next time you come back to the work, you open the script file you saved. Okay. The only thing you need to do is run everything toward the end. From the beginning to the end. Yeah. Yeah. Mm-hmm. Okay. Yeah. Yeah. But I will show you. Actually, that is part of the slide, I believe. Okay. All right. All right. So that's the end of the blue part of this diagram, step number 11. All right. And then next few slides, I will quickly go over, okay, resuming existing work. Okay, so step number 3 in the bottom, not the top, but in the bottom. Okay. So, okay, step 3 in the bottom, open RStudio, and step 4B, which is the green part in the bottom here, open a saved R script file. Okay, these 2 steps can be done by many different ways. If you did not close the RScript window before closing RStudio, it will automatically open when RStudio is reopened. As I said earlier, RStudio is nice enough to recover the, cache the whatever you had when you close the RStudio, which means that it will open up the, script files and actually, data viewer too, if you didn't close them, when you close the RStudio, okay? Or double-click the R script file icon, and if it is the if RStudio is installed in a way that it links to the the file extension, file type, double-clicking on the script file will open up the RStudio. So that is another way. And also within the RStudio, go to File, Recent File, and choose the target R script file. Or similarly, go to File, Open File, and locate the target R script file. Or within RStudio, click on the folder button, which is the same thing as the previous one. It will open up the dialog box to choose the file that you want to open. Okay, so maybe I will demonstrate that part. Okay, so let me save. So I will show you here. Okay, let me close. Okay, so again, this is the dialog box I was talking about, but I recommend don't save. Okay, and then okay, open the RStudio, and without doing anything, it will open up the two script files that I have. Okay, but if I close those script files before closing the RStudio, and then if I open the RStudio, it doesn't open up the script file. So in that case, I have to do something. Okay, so for example, one option is the go to file and recent file, and they will show the last 10 files or something. And then you can choose, the target file, which should be, like the in this case, this one, right? Or this one. Okay, so like this. Or, you can go to file, open file, and it will open up the regular, dialog box to locate your file. That's another way. Or, okay, let me close it. And then, or, use this button, the same thing. Things like that. Okay. All right. Okay. Okay. And then to resume the work, basically we have to start from the setting the walking directly, which is the 6B right here. So that is a part of the diagram, 예쁜데? And then read the data file. And also, it is not explicitly setting here, but you have to load all the packages that you are going to use. Okay, and then go through the step 8 through 11 as same as before. Okay. All right. So as a summary for this slide set, you're highly encouraged to replicate exactly the same process on your computer, and you're highly encouraged to replicate the same process with your own data. Okay. So that would be a good practice. And the next step is I will show some more basic statistics and the graphing procedures. And also, if time allows, I would like to show you how to produce a document by RStudio by integrating analysis and graphing by R. So actually, RStudio can produce the very nice HTML document, PDF document, and also Microsoft Word document. So integrating all your code and the graphics and analysis results. And it's very beautiful. It can produce a very beautiful document. So this will be very nice, very nice way to share, your work with others by like HTML document rather than, copying and paste, that would be a lot of work.